We are back with another lesson. In this lesson, we'll discuss interference of light, your Young's double slit experiment. So, what is interference of light? Now, when two light waves of same frequency and having zero or constant phase difference traveling in the same direction superpose each other, fine. The intensity in the region of the superposition gets redistributed, becoming maximum at some points and minimum at others. This phenomenon is called interference of light. Now, so what happens in interference of light? When you are when there are two light waves, okay, there are two light waves. Suppose this is one light wave and this is another light wave. When there are two light waves having the same frequency and zero or a constant phase difference, okay, so can you see you have two light waves, okay, these are your two light waves. This is your first light wave, this is your second light wave. So when two lights having the same frequency, okay, so this is just an expression, okay. So uh, let's see, what do you mean by frequency? Can you see this change in the wave shape? If I change this f, what is changing? It's frequency. Can you see what is happening? Okay, or let us go here with one. So what does the frequency means? Frequency means how fast it completes one cycle. Can you see? At this point, how much is the value? 0. Similarly, at this point, how much is the value? 0. So how fast it completes this cycle is the frequency. If I increase the frequency, okay, earlier my frequency was 1. Now let us increase the frequency a little bit. Okay, let us keep at 2. Let us double the frequency. Fine. We have double the frequency. So this is your frequency 0. It starts from here and now it completes the one cycle here at 0. So what you have noticed that it has completed this cycle faster as compared to your previous case. So by how much or at what rate it completes this cycle is known as your frequency. Fine. So when two light waves, this red light wave and this blue light wave, when both of these light waves of same frequency having zero or a constant phase difference. Okay, so what do you mean by phase difference? To understand your phase difference, look here. At the point 0 on the x-axis, okay, at point 0, how much value I'm getting? 0. But at the point here, let me keep the frequency 1 for now. Now, at this point, at pi by 2, how much value I'm getting? 1. At pi, how much value I'm getting? 0. At 3 pi by 2, how much value? Minus 1. At 2 pi, how much value? 0. Fine. So have you noted these values? Okay, just note these values. At 0, I'm getting how much value? 0. See, at this is your x-axis. When x is 0, when your x is 0, along the y-axis, this one is your y-axis. Along the y-axis, how much value you are getting? 0. Consider your this point. At the distance of pi by 2, pi by 2 means 3.14 divided by 2, okay, or let us consider this value. This value is how much? Pi by 2 on x-axis. How much value it is? Pi by 2. On y-axis, how much value we are getting? 1. Fine, this value is 1. Clear? Similarly, on the x-axis, pi. On the x-axis, pi. Okay, you can use your calculator to check the value of pi. Pi is how much? 3.14. So it is between 2 and 4. So 2, somewhere here it will be 3 plus 3.14, somewhere at this point. So when your x-axis is pi, that is 3.14, how much value are you getting along the y-axis? You are getting 0. Fine. So at pi by 2 on the x-axis, how much value you are getting on y? 1. At pi on the x-axis, how much value you are getting on the y-axis? 0. At x equals to minus 3 pi by 2, how much value you are getting here? You are getting minus 1. Fine. This is one phase. Okay. This is one type of phase. Fine. This is one type of phase. Now let me change the phase. Let me introduce a phase difference. Suppose let us say, okay. Now I've introduced a phase difference. Okay. Now when I introduce my phase difference, what happened? See, earlier at point 0, how much value I was getting? 0. But am I getting the same value now? No. The value on the y is coming somewhere at 0.909. Right. Now similarly at this point, okay. Earlier we were getting 0. Okay, let me just bring that earlier graph also. Okay, for now consider this blue one. This blue is your previous graph. Okay, this blue is your previous graph. Let me just show it with a dotted curve. Okay, fine. This blue is your dotted curve, and let me just put it on top of each other to compare the values. Okay, now in your previous point at 0, how much value you should get for this blue curve. This blue curve represents your old curve. Okay, so at 0, how much value you should get? You should get 0. But if I change the phase, see this P, if I change this phase, what happened? Now you are getting 0. No, now you are getting some value 0.909. Can you see this point? Fine. Now let's go back to your previous curve. At this point, at the value of pi by 2, on this point somewhere here, how much value I was getting? 1. But when I change the phase of the new wave, am I getting the same value? Check here, somewhere at this point. Am I getting the same value? No. How much value I'm getting? Minus 0.433. Fine. So can you see the wave has moved little bit other side. The wave has moved previous curve. The red one represents the new curve with a different phase. Fine. So this red wave has a different phase difference. Different phase difference, therefore your red curve has shifted in your left position. Right? Can you see in this picture? So this shift in the position is known as your phase. Fine. Okay. But we need a constant phase difference curve. Okay. The phase difference should be 0 or either a constant. So let us consider two curves of same phase difference. Fine. This yellow, this dotted blue is your first curve, light wave. This red one is your second light wave. So this we are considering light waves having the same phase difference. Okay, let me put this phase difference as 1. Fine, or 0. So according to your Huygens principle, when you have light waves of having same frequency, fine, having same frequency and say 0 or a constant phase difference, okay, then the intensity of the light. By intensity of light, I mean the brightness. Okay, some places it will be more bright, some places will be less bright. Okay, this is means by your intensity. Okay, how much bright is your light is your intensity. So if you consider two light waves having the same frequency and a 0 or a constant phase difference traveling in the same direction, the two light waves will superpose each other. The intensity in the region will get redistributed. That means at some places you will get a very bright image, At some places you will get dark images, that means no image. At some places you will get a bright image. At some places you will not get dark image, or you will get a dark image. Fine, no image. Yeah. If this is plain white, that means this is completely dark. Okay. So here you are not getting any image. You are not getting any light at this point, but you are getting a light at this point. You are getting light at this point. You are getting light at this point. So this distribution of the intensity of light. Okay, this distribution of this intensity, or this phenomenon by which the intensity of the light gets distributed, is known as your interference of light. Fine. Apart from this, I will send you the link for this web page. Okay. Here you can change these values to see what happens, how your waves changes, what happens if you changes this phase difference, what happens if you change this constant. Okay, you can play around with this curve to understand, to get a better understanding. Okay, fine. So this is your interference of light. Now in today's class, we'll discuss the theory about the interference of light. Why such distribution occurs? Fine. And in our next class, we will derive the mathematical part, where we will see, where we will show why you get a why you get a maximum intensity, why you get a minimum intensity at this point. Okay, by deriving. Fine. So let's start today's class. Okay, so in our last class, we have said that your light source emits light in form of your waves. Okay, they produce light as spherical waves. So this source is producing light waves. Okay, now this light waves falls on the observer as a plane wave. Fine. This is what we had discussed in our previous classes. Fine. So similarly, consider such a light wave. Okay, such light waves, this plane light waves, they are falling on this slit. This, by slit I mean small opening. Fine. Now as soon as they fall on this slit, okay, what happens? This slit acts as a source of your secondary disturbance. From this secondary disturbance, the wavefront will start to rise, as you can see in this picture. Fine. This is the side view, this is the top view. Fine. Now in this picture, this white spot represents the maximum intensity. That means it is the crest. By crest I mean the upper part of the wave. Okay, the upper part of the wave, the max. And this black part represents trough. So trough is the lower part of the wave. Fine. This is your lower part of the wave. So this whole spot is the crest. Okay, there are different waves with, okay, let me just show. By I mean this, at this point you have crest, at this point you have trough. Fine, crest, trough. Similarly, crest, trough. Similarly, crest and your crest and trough. Fine. This is how it looks. This is the upper part of the wave. This is the lower part of the wave. Fine. This is the upper part of the wave. This is the lower part of the wave. So these shows the wave picture. Okay. Let me just rub this one. Fine. So you can see in this picture, as the wave passes through the slits, the wave propagates in the forward direction. Fine. But according to your Young's double slit experiment, we need two uh, two light waves. Okay. For this, what we can do is, let us consider a source. Fine. Let us place a source here. Now, in front of the source, let us place the slits. Okay. Now, if you put the slits at this point, then in such case, what do you expect? A light waves will be produced. Okay. This light wave will look uh, cylindrical in shape. Okay, okay, if you can imagine it, this is how it will look. This light wave, they will look cylindrical in shape. Fine. Okay, this is half section of the cylinder. Can you see? Suppose if I have to draw a cylinder, this is your cylinder. Then this represents the half section of the cylinder. Fine. This one represents the half section of the cylinder. So if the source of light passes through the slits, what happens? You get a cylindrical wavefront. But if we look from the top, okay, if we look from the top, from this point, what you will observe is that you will observe this curve wave like this. Okay, you will observe curve wave like this, what you have seen in this picture. Can you see? You will observe a curve waves like this. Fine. Now, since we need two light source having same frequency and zero or a constant phase difference. Okay. Now, it is obvious that we cannot get two light sources which has the same frequency having zero or a constant phase difference. There will always be some slight error. Okay, there will always be some error. If the frequency is same, the phase difference will not be same. If the phase difference is same, the frequency is not same. So in order to eliminate this error, what we can do is, instead of having a two light waves, what we can do is, we can consider the same light waves. We can consider the same light waves and make them pass through the two slits. In such a way, what you observe is that you will get two light waves. Fine, you will get two light waves. Both of them will have the same frequency and both of them will have a same phase difference. Fine. In such a way, we can get your two light waves. Fine. Now, as you can see in this picture, we had the plane wavefront coming from your slit S. Now they fall on the two slits. Fine, they fall on the two slits. What happens? You will see the interference of the different light waves. Fine. As you can see in this picture, the plane waves, the plane waves are incident in this direction. Fine. After passing through the slits, each slit will produce a wavefront. Okay, they will produce a cylindrical wavefront, but from top view they will look like a semicircle. Okay, from the top view they look like a semicircle. Similarly, this slit also produce light waves. This slit will also produce semicircle wavefronts, as you can see in this picture. Fine. Now, what happens? The light waves coming from this two slits, they interfere with each other. Okay, now let's see how they interfere. When you have two light waves coming and they interfere, Okay, they superpose each other. Okay, by interfering with each other, I mean they superpose with each other. The two waves are superposing each other. If the two waves superpose constructively, that means the crest and the crest, the trough and the trough falls on top of each other, as you can see in this picture. Fine. In such case, the resultant wave will have the, can you see this green wave? This resultant wave will have the maximum intensity. Fine. Okay, let's take a look here. So consider your light coming from your slit S1. Okay, for crest, okay, for the crest, I will use red pen. For the trough, I will use blue pen. Fine. So now let's look at the light coming from your slit S1. So first you have a trough. Okay, this is your trough. Fine. Then you have the crest. Okay, wait just a minute. Fine, as shown here, look, this is the crest, the one which I have drawn with the red. Can you see this red one? This represents the crest, the upper part of the wave. Fine. Now I'll draw the downward part of the wave, trough. This is your trough. This is also your trough. Okay, let me just draw it properly. Fine. Yeah, again another trough. Fine. So similarly, you have a repeated crest and trough, and so on, which is coming from your slit S1. Now similarly, consider the light which is coming from your slit S2. Now let us draw the crest and trough for your slit S2 as well. So first you have a trough, then you have the crest which I'll draw with the red pen. Then again you have the trough, and then again you have the crest. Fine. So similarly, there is also the repeated pattern of the trough, crest, and so on. Now, in this pattern, if you see, just now we have discussed if your crest and crest falls on top of each other, let us consider this source S1. Fine. For this source S1, consider this part, this crest. Okay, this is your crest. Similarly, for the source S2, consider this crest. Fine. So at this point, the two crests, are they matching with each other? Yes. Now let us consider for the trough part. Okay. Consider this trough part, this one. Similarly, consider this trough part. Fine. So at this point, what happens? The trough and the trough, they coincide. Now, when trough, crest, trough, and crest, trough, and crest, they superpose each other, then in that case, what happens? Then you will get a resultant wave which has the maximum intensity. That means the intensity, okay, by intensity you can also understand its amplitude part, by how much displacement it is along the y-axis. Okay, so if the two waves interfere constructively, that means crest falls on crest, trough falls on trough, then in that case what happens? You get a resultant wave which has a maximum intensity. This is according to your superposition principle. So if you look in this picture, look at this center part. Okay, you have a crest and crest coinciding, you have trough and trough coinciding, you have crest and crest coinciding. Again, this black part represents the trough part, the down part of the wave. They coincide. Now, if they coincide, okay, that means at this point you will get a maximum intensity. Fine. You will get a bright spot here, as you can see in this picture. Fine. Now, what happens when crest intersects with the trough part? Fine. Now, in this picture, you can see. Now, in this picture, you can see this red one represents your first wave. Okay. At this point, look at this point. Fine. For the first point, similarly, this purple one represents your second light wave. Look at this point. Fine. At this point, what you notice are the crest intersecting. No, in this case what is intersecting? Your crest and trough are intersecting. If your crest and trough are intersecting, then in such case what happens? You get a resultant. Okay, the result, the output of this such interference will be zero. That means destructive interference. The two waves are cancelling each other. That means they are destructing each other to give no wave at the output. Such kind of interference is your destructive interference. Fine. So look again into this picture. Okay. Let me just skip some crest and trough. Okay. Let us start from here. For the slit S1, okay, this represents your crest and this represents your trough. Fine. Similarly, this represents the trough and this represents the crest for the light coming from the slit S1. Fine. Now let us consider for your light coming from your slit S2. Fine. So for this light, this represents the crest, this represents your trough, this represents your crest, this represents your trough. Fine. Now, if you look at this point, okay, you have a red line, that is the crest coming from your slit S1, interfering with, okay, which part? Uh, Beta, let us consider, let me just mark it. Okay, if I don't mark it, even I get confused. Okay, let us consider this part. Okay, consider for this part. Now, for this point, you have a trough coming from your slit S1. This is the trough of the light wave coming from your slit S1. Fine. Now consider this crest for the light coming from the slit S2. This represents the crest for the light coming from slit S2. So at this point, what you notice is that the crest intersects with the trough. Fine, can you see? The crest is intersecting with the trough. So at this point, what happens? The two waves cancel each other. Similarly, throughout this length, okay, the two waves cancel each other. Throughout this length, the two waves cancel each other. Throughout this length, The two waves cancel each other. Fine. So if the two waves cancel each other, then in that case, what happens? You get a dark spot at those points. Okay. That means the two light waves has cancelled each other. Therefore, there is no light appearing on the screen. Hence, you get a dark spot. Fine. As shown in this figure. So you have a pattern of a bright fringe, you have a pattern, you have a bright fringe, you have a dark fringe, you have a bright fringe, you have a dark fringe. Okay, so this pattern of bright and dark fringes, okay, this pattern is known as your interference. Okay, and the phenomenon by which you can produce this interference, this phenomenon is known as your interference of light. Okay, and this experimental setup by which you can perform this experiment, okay, this experiment is known as your Young's double slit experiment. Fine, so let us look at a demonstration of a Young's double slit experiment. Okay, so here the experimenter is allowing the light to pass through a single slit. Okay, when he allowed the light to pass through a single slit, in that case at the screen, okay, somewhere at this point, what he noticed is that a single bright spot. Fine, he notices a single bright spot. Now after some time, he allowed the light to pass through double slits. Okay, he introduces the double slit. In this case, what happens? The light, after passing through the double slit, produces interference pattern on the screen, as shown in this video. Fine. So can you see there is a spot where you have a maximum intensity, zero intensity, bright fringe, dark fringe, bright fringe, dark fringe, bright fringe, dark fringe, and so on. Fine. So this pattern of bright fringe and the dark fringe is known as this interference pattern. Okay. And the spot where they interfere to produce the bright fringe. Okay. Such kind of interference is known as your constructive interference. And the spot where the light waves interfere to give a dark spot. Such kind of interference is known as your destructive interference. Fine. So in our next class, we will derive the condition for your bright fringe or your constructive interference and condition for your destructive interference. And after this, in our next class, we will derive the width. How much will be the size of this bright fringe and the dark fringe? Fine, fine. So in this picture, I've shown how the two waves superimpose to give a bright fringe, how the two waves interfere destructively to give a dark fringe at this point P1. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.